Right, let's prove that PV equals a third NMCRMS squared. To do this, we must imagine a box with dimensions Ly, Ly, Lx, Lz. And then we must imagine a particle inside this box of mass m, velocity v, defined by v equals vx in the I direction plus vy in the j direction. That's vz in the k direction. Now the force on this wall will be equal to the rate of change of momentum with respect to time, which is delta p on delta t, which would be 2vx, because it bounces off with the same speed it went at the wall at, because it's an elastic collision, times by m on the time, which would be the time taken to go for the particle to go from one wall to the other wall and then back to the original wall. So that time would be equal to 2Lx on Vx. Subbing this in, we see 2Lx on Vx. And this is equal to mVx squared on Lx. Then the pressure on this wall, done by the particle, would be equal to the force over the area, which would be equal to mVx squared on Lx, Ly, Lz, because as you can see the area of this wall here would be Ly times by Lz. And then we can write, since velocity equals Vx in the I direction plus Vy in the j direction plus Vz in the k direction, and we want to find the average speed of the molecules, or if we first square velocity, so the magnitude of the velocity squared equals Vx squared plus Vy squared plus Vz squared. And we're going to find something called the root mean square, which is essentially the average speed of any of the particles in the gas. And to do this, we can simply imagine in a gas, random motion, and the velocity in the x direction, velocity in the y direction, velocity in the z direction, all sort of equate to be the same rough thing. There's a sort of slight symmetry there, that the randomness creates an indistinguishability, and so we can write root mean square, RMS, speed squared equals 3Vx squared, because we're saying that Vy, Vx and Vz are sort of roughly the same thing. Therefore, Vx squared equals a third CRMS squared. Now putting this back into the original equation, we get P equals m CRMS squared on 3Lx Ly Lz, and Ly Lx Lz is obviously volume, so we can write PV equals a third mCRMS squared, and then for n particles this becomes PV equals a third NMCRMS squared.